Today's lesson is 6.3b, add and subtract rational expressions with unlike denominators. In our last lesson, we learned what to do with when our rational expressions had unlike denominators, and we had to find the LCD. So just a really quick reminder that the LCD is really the least common multiple, and so you're looking for that number, the least common multiple of two or more integers is the smallest positive multiple they share. And here's our example of 4 and 6 again. 12 would be their least common multiple because remember we talked about 2 times 2 for 4 and 2 times 3 for 6. We're going to take the 2 that they share once. Then we have to take the 2 from the 4 and the 3 from the 6. 2 times 2 is 4. 4 times 3 is 12. And that's how they came up with the 12. This is another way of doing it. They just kind of listed out all the multiples. So 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6. And then they did that with 6, and then they found the smallest one that they shared. Remember when we have variables that we take the largest amount. So if we had 4x squared and 6x cubed, our least common multiple would still be 12, but we would have to take all of the x's. So we'd have to take x to the third, okay? All right, let's go ahead and get started. So these look very similar to where we started with our first one, where they were exactly the same. But notice -5 and +4 are totally different. And so we have to go ahead and we have to find our LCD. Now, because these two are totally different and neither one of them can be factored, they are already, in fact, a factor, we can go ahead and our LCD is going to be our first denominator as a factor times our second denominator as a factor. And of course, we don't have to actually multiply them out. We can leave them like this because remember, if we end up being able to factor the numerator, they will cancel out. And so we're just going to go ahead and leave them just like this, okay? All right, let's go ahead and start seeing what we need to multiply. In something like this, it's actually pretty easy. You look at what you have and you cross it out, and we're going to multiply it by that one. And if you take a look, this is exactly the other denominator. So if we go back and use our highlighters, this is exactly the peach highlighter, okay? And so over here, if you take a look at it, come take a look, cross that out, this is what you're going to multiply by. And if you look, that is the yellow denominator. That is my yellow denominator. So there's a lot of different ways that you can help yourself to remember what I should multiply by. Now here is my denominator, my LCD, my common denominator. There it is. And on the top, I'm going to do x plus 4 times 3. So I'm going to have to distribute that 3. And in the second one, here's my least common denominator, the two of them together. And I'm going to have to distribute this as well. All right, so the next step I'm going to do is I'm actually going to go ahead and distribute this 3. I'm going to get 3x plus 12. And here I'm going to distribute my 4, and I'm going to get 4x minus 20. I am adding, so nothing's going to really change. Nothing's going to change in my numerator. So I'm going to have 3x plus 12 plus 4x minus 20. I don't have to worry about distributing this because a positive and a positive is going to stay a positive, and a positive and a negative is going to stay a negative. So this is going to stay what it is. It only changes when I have my subtraction. Let me copy down my common denominator. There we go. Now, I have to look at my numerator before I say I'm completely done. And there's two things that you're looking for in the numerator. You're looking for, can you combine together like terms? That's the first thing. Once you've combined together your like terms, then you want to look to see, can you factor? Should you factor? Okay, so let's go ahead and combine together our like terms because there are 4 of them. So let's combine together our x's and let's combine together our constants. Okay, so 3x plus 4x is 7x, and 12 minus 20 is negative 8. Notice I have not multiplied out that denominator. I'm still holding out hope that I can cancel something or that my numerator is just not factorable. All right, so now we're at the point where we have to look at our numerator and we say, can we factor? Is there a number that divides into both 7 and 8? And could it possibly leave us with a 5 or a 4? Well, the problem is 7. 7 is a prime number. It is 1 times 7, and that is it. So 1 times 7, 8 is 1 times 8, and 8 is 2 times 4. So there's no way that it's going to factor. This is my answer. I don't have to multiply out the denominator. Let's try another one. All right. Remember, it's always a good idea to go ahead and take a look at your denominators as they are given to you. And this one, I'm going to have to change my color. This one is making me subtract. All right, so I have to actually go ahead and do a little bit of looking at this one because I'm not quite sure about my LCD. So I'm looking at 4x minus 5, and it looks like a factor, but because there's that 4 in front of the x, I'm thinking, could I divide 4 and 5 by a number? I can't. 4 is even, 5 is odd. I'm just going to go ahead and make that into a factor. Yes, I could think of 6 as 2 times 3, but there's no need for it right now. So I'm going to keep it as times 6x. So there's my LCD. I'm just going to go ahead and multiply the two of them together. So maybe this one isn't as bad as I thought it was going to be. All right, let's go ahead and start looking at what do I need to multiply the yellow one by so that it becomes this new LCD. So remember, you're going to focus on this and you're going to cancel it out of your LCD. This is what you multiply by. What you do to the bottom, you must do to the top. And notice, this is my peach factor. This is my peach factor. All right, let's do the same thing for the 6x. This is what you have, cross it out. This is what we're going to multiply by. What we do to the bottom, we must do to the top. And if you take a look, this is your yellow factor. All right, let's go ahead and start multiplying. I like to put the denominator first, simply because then my rational expression doesn't look off balanced, but that's just me. All right, so that's what I have in the numerator. Minus, here's my second one. And, ooh, uh-oh. I think I might have to multiply that out. In fact, I'm pretty sure I'm going to have to multiply that out. Let me go ahead and grab my lighter color. I'm going to have to double distribute this. So I'm going to have to go ahead and say x times 4x and x times minus 5. Then I'm going to have to say negative 1 times 4x and negative 1 times negative 5. These two will combine together to give me 4x squared minus 9x plus 5. So these two are where I got the minus 9 from. Then don't forget, you also have to distribute the negative. So the negative is going to go and make this a minus, it's going to make this a plus, and it's going to make that a minus. So here we go. Let's go ahead and start combining them all into one big fraction. 6 times x is 6x squared. Remember, we said it's going to be minus 4x squared plus 9x minus 5. We have to go ahead and distribute this negative through to this whole polynomial. And then my denominator is going to stay like this. All right, I do see that there are 4 terms in the top, so chances are that there is a common term that I can go ahead and combine together, and it happens to be my 6x squared minus my 4x squared. So that would become 2x squared. Move down here. That would become 2x squared plus 9x minus 5, and then I have this in the denominator. Hmm. Can I factor the numerator? Yeah, I could factor the numerator. Um, let's just take a look at this and this. Let's just take a look at this and this. So 2x squared would have to be x times 2x. And 5 would have to be 1 times 5. So I'm going to get something like x plus 1 and 2x minus 5, something like that. Notice, yes, I have a minus 5, but I have a 4x, not a 2x. The only other way this 2x minus 5 could be is it could be x minus 5. Is it going to cancel out with this? No. So should we factor? No. We're not even going to have to factor. This is our answer. This is our answer. All right. If you were in class today, we did have a you try again today. So here was the you try. And I did help a little bit with this one because one has a common denominator. Or, well, this one has a multiple. So one thing I noticed with this one, when I went to start to do the least common multiple, is that 4x plus 12, there we go, plus 12, I can divide both of those by 4. And if I divide both of them by 4, I end up with this. Now take a look at your other factor, or your other denominator, right? So notice, what do they have in common? Let's circle it. They have this in common, and then they have the 4. So our LCD is going to be 4 times x plus 3, or 12x, or sorry, not 12x, that's not right. 4x plus 12, right? When I multiply it out. All right, but I want to think of it as 4 times x plus 3. And so I'm going to go ahead and I'm going to say, well, what do I need to make this denominator be my LCD? What do I need to make this become that? Nothing. I don't need anything. So I'm going to do a 1 and a 1. I actually don't have to multiply this one. Okay. What do I need for this to become this? Well, I have that. All I need is 4 so that I can become 4x plus 12. So times 4 times 4. Let's go ahead and start multiplying. Ooh, I need a little bit more space. There we go. 4x plus 12. And I'm going to have 1 times 13 minus, I forgot to remind myself I was subtracting, and then 4x plus 12 and 3 times 4. All right, 1 times 13 is 13, and 3 times 4 is 12, so I have 13 minus 12. 13 minus 12 is 1, so I have 1 over 4x plus 12. Is there anything to worry about factoring? No, that's my answer. All right, let's take a look at the next example. And I'm pretty sure at this point you're like, we got this. But take a look at these two. I have to factor those so that I can find my LCD. I have to factor those so that I can find my LCD. And notice they are asking us to add, so that's going to help quite a bit. All right, let's start finding our LCD. So let's start by taking our 3x squared minus 14x plus 8, and let's factor it. So 3x squared is going to be 3x times x, and 8 I can think of as 1 times 8, or I can think of it as 2 times 4. Now I've got to decide which one I'm going to use, and I'm thinking I'm going to try, let me grab my, I'm going to try this one. I'm going to try 2 times 4 because I think that that will help me get to the 14. So I'm going to put x on the top and 3x on the bottom, just because I do like it that way better. And then I'm going to start thinking, I need 14. So I'm going to try the 4 here because 3 times 4 is 12, and that's pretty close. And I'm going to put the 2 right here. So let's go ahead and grab our color and let's start multiplying. So there's my 12x and my 2x. If I add them together, can I make them be negative 14x? Well, yeah, negative, negative, and I've got negative 14x. So minus and minus. Here are my first factors. Here are my first factors. I'm going to put them in that purple. So I've got x minus 4 times 3x minus 2. There's my first one. Let's grab our second denominator. And let's go ahead and let's factor this one. So 3x squared, let's think of it as x times 3x because I like that better. And 2, even though it's negative, it's 1 times 2, so that's not so bad. One of them is going to be negative. So I've got x and I've got 3x. And 1 and 2, let's see. Let's try 1 and 2, and then we'll see if we have to fix it. So 3x times 1 gives me 3x. X times 2 gives me 2x. Can I add them together and get 1x like I have right here? Yes, I can. Yes, I can. Positive 3 and negative 2 give me positive 1x. So I've got plus and I've got minus. Be very careful. It was very easy for me to make a mistake with my pluses and my minuses. There we go. So now for my LCD. Now for my LCD. Ooh, I hope I still have enough space. I'm going to take what they share. And what they share, I'm going to put, let me think. Let's put a line underneath it. What they share. So I'm going to start with the one that they share. And then I have to add both. So I need this one. And I need that one. So just to help me out, I went ahead and used some different markings underneath them so that I could very quickly see what did I need? What do I need to multiply by? All right, let's go back up here. And here we go. So this denominator has these two. So I need this one, right? Because this one's out as well. If this one's out, that one's out because they go out together. So I need x plus 1. I need x plus 1, bottom and top. All right, let's look at this one. Well, this one has these two. Remember, if this one goes, this one goes. So I need x minus 4. Bottom, top. Whew, that was tricky. All right, here we go. Here we go. I'm going to move down here, and don't worry, I've got plenty of space, and I know what's up there. So I have 2 times x plus 1, and then I have my common denominator, what they share, and the one from each of the other. Plus 1 times x minus 4 and then my common denominator. Now, it's a very common mistake to start trying to cancel out, to say boom, 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 boom. You cannot do that. You cannot do that. You're going to have to go ahead and distribute. That's your next step. Distribute these and then combine together your like terms and then see if you can actually cancel out. So let's go ahead and distribute. So 2 times x is 2x plus 2 times 1 is 2 plus from the middle 1 times x is 1x and 1 times minus 4 is minus 4. Okay, so that's our next step. Don't get cancel happy yet because then you're just going to go back to where you started. Okay, now you're going to go ahead and you're going to combine together your like terms on the top. You're going to add together the 2x plus the 1x, and you're going to combine together the 2 minus the 4. So here we go. 2x plus 1x is 3x, and 2 minus 4 is minus 2. Hey, wait a minute. Take a look at this. If I were to just put that in parentheses, it would cancel with this factor and then they're gone. And you can do that. That's exactly what you want to see. That's exactly what you want to do. What is left is your answer. So you might be thinking, well, all I have is this. All I have is this. But remember, whenever you cross everything else out on top, you have a 1 left, and there's your answer. I do have one last example, and the last example is going to go over this concept, but there's 3 of them. So we're going to write this as a common fraction, and notice we've got 1, we've got 2, and we've got 3 different ones that we have to take care of. They're not telling us to add or subtract because notice we have an add between the first 2 and we have a subtract between the second 2. We're going to go ahead and do our LCD. We're going to start with our LCD, and we're going to start by going ahead and factoring all 3 of our denominators. So let's get going because it's going to take us a little bit of time. So x squared is x times x. Remember, I stacked them. And 24. Okay, I've got to think because there's quite a bit for 24, like 1 times 24, and 2 times 12, and 3 times 8, and 4 times 6. So I've got to think about that. Which one of these is going to give me 5? Well, if I take 3 away from 8, I could get 5. So I'm going to try 3 and I'm going to try 3 and 8. And it doesn't matter. Oops, I'm in the wrong color. There we go. 3 and 8. And it doesn't matter which one I do, which one I put where, because they're going to go ahead and I can make it work. It's just not going to matter which one goes on top and which one goes on bottom. I need a 5x. I need a 5x, right? And we said, right, 8 minus 3, there we go. There it is, and we get our 5x. So our first set is going to be x minus 3, x plus 8. All right, maybe this won't take as long as I was thinking. I hope not. Ooh, 40. Come on, Alex. That's a big number. Well, let's stop and think. We have 40, but our middle term, what they need to add to needs to be 3. So 1 times 40 isn't going to work. 2 times 20 isn't going to work. Um, 4 times 10 isn't going to work. That's 6. 5, oh, 5 times 8. There we go. 5 times 8. We can make that one work. I mean, if 8 and 3 becomes 5, wouldn't 5 and 8 become 3? I think so. crisscross multiply. And yep, we can go ahead and make this become 3x if we subtract the 5 from the 8. So minus and plus. Here is our next set. And then let's stop and let's take a look at what's the same. What's the same between these two? Well, I've got this and I've got this, right? Those two are the same. So I know for sure x plus 8 is going into my LCD, but only once. All right, we have one last one to factor. Oh my gosh. Now, one thing that I'm noticing is that I used a 5 in the last two. So I'm thinking I might want to use 3 times 5 for 15 because the only other one is 1 times 15, right? 1 times 15 is my only other one. So I'm thinking I'm going to want to use that. And I'm pretty sure that 3 and 5 will give me 8 when I crisscross multiply because 3 plus 5 is 8. But I need a negative 8. So that just means that they both have to be a negative for me to get negative 8. Oops, I forgot my check mark over here. All right, there we go. And so now my last two factors are this. Let's see what we have in common. So notice right here, I have this and I have it again. So I only need one of them. And then take a look at this. Oh my gosh, you guys, look. They match too. So even though it looks like I have 1, 2, 3, 4, 5, 6 different factors, I really only have 3 different factors. I have these guys, I have these guys, and then I have the wiggles, right? I have the 2 wiggles. So there's my LCD. Here's my LCD. And it doesn't matter which order you put them in. I'm just going to put it in the order that I see. Um, the, the stripes, then the line, then the wiggle, because that's the way I see it from left to right here. So I just put it there. Okay, that's the only reason why. Now I'm going to help myself out by what to multiply by taking a look at what this one has, which is these two. Okay, so this one has these two. So cross them out. I need to multiply by this guy, minus 5. All right, same thing. Look at this one. You're going to cancel out these two. Goodbye, goodbye. So we're going to multiply by x minus 3. Okay, and for the last one, you're going to take a look at these two, cross them out, and we're going to have to multiply by this guy. There we go. All right, so let's go ahead and start our multiplication so that we can finish up this problem. Ooh, this one's going to be a long one, I feel. I really feel like this one's going to take me a long time. So I've got 2x times x minus 5 plus I've got 5 times x minus 3, and then I've got my common denominator, minus, so don't forget that we might have to distribute up here, that negative. There's my numerator. Let me see if I can squeeze in my denominator. Whew, made it. All right, let's go ahead and let's distribute. So we're going to distribute and distribute. All one big long denominator. So 2x times x is 2x squared minus 2x times 5, 10x. We're going to go ahead and distribute here, and we don't have to really worry. Plus 5x minus 15. We're not worrying because we are adding. Now we need to be a little bit careful here. Let's go ahead and distribute first. Right, let's go ahead and distribute first. Okay. And then we have to remember to go ahead and distribute the minus. We have to remember to go ahead and distribute the minus. So minus 2x minus 16. All right, let's go ahead and combine our like terms. Like, the 10x, the minus 10x, and the plus 5x, and the minus 2x. Those guys are going to combine together. And then we have negative 15 minus 16. So we're going to combine together those. There's nobody to go with my 2x, and I forgot to put my denominator, so let me go ahead and add my denominator super fast. There we go. All right, so I've got 2x squared minus 5x, and negative 15 and negative 16 is going to be negative 31. Okay. All right, so you might be thinking we're done. But remember, we have to check the numerator. Can we factor it? Can we factor it? Can we factor it so much so that one of the factors in the denominator will cancel out? So remember, you're looking at your 2 and you're looking at your 31. You always look at the first and the last one. Well, this is going to be x times 2x. So I could have a factor with an x in it, and I see that I have 3 of them down here. So there's a possibility. But take a look at 31. The only thing I can think of that's 31 is 1 times 31. None of these numbers is a 1. None of these numbers is a 31. So we do not have to factor the numerator. In fact, it may not even be factorable. And there is our final answer.